In this video, we're going to do some guided exam question practice on the question 11 from the 2022 mock paper that we did, okay, in my class. If you weren't in my class, maybe you had a different mock, no problem, and then just treat this as practice. Have a go at it. Okay, so the first thing we're going to do is we're going to take a look at the blurb. Well, it's what 30 marks as well, which suggests to us that about 10 minutes is the time that we are allowed for this. So again, get your timer set for 10 minutes and get stuck into it. All right, it says wind turbines can be used to generate electricity. Nothing new for us there. It says the diagram below shows how the hub height and rotor diameter of the wind turbine have changed over 3 decades. So see here, from here to here to here to here, what's happening is we're going through the decades. So this is 1980 to 1990. This is 1990 to 95, 95 to 2000. So in general, hopefully you can see the pattern is that the wind turbines are getting bigger. Okay, so they're increasing in height and they're increasing in the diameter of their rotor. So the diameter of this circle that we can see here, this circle is what we would call the diameter of the rotor. So it measures basically a circle on the outside of the 3 wind blades, if you like. Okay, so this here shows the hub height. And you can see from here information about the radius of the circle. Okay, so yeah, so you can see by the circle getting bigger that obviously the radius is getting bigger. Okay, hopefully you guys can see that. All right, so it says here, using information given above, describe what happens to the power rating of wind turbine when the rotor diameter is doubled from 50 meters to 100 meters. Right, so the first thing that we want to do is find the rotor diameter at 50 meters and the one at 100 meters. Well, here is the rotor diameter. There it says 50. So pause the video and find the one for 100. Okay, so hopefully you can see that is here. So the 2 blue marks show the rotor at 50 meters and the rotor at 100 meters. What we're going to do now is zoom in on the power rating. So the power rating is measured in kilowatts. So here you can see 750. And here you can see 3,000. So what you had to do is, sorry about that, guys, a bit of an announcement there. Yeah, so here it says describe. So you just have to describe. Okay, so what I want you to do is pause the video, write down part A, and write an answer that describes what's happening. Use as much detail as you can. Okay, so pause the video and do that. Okay, so you should only be playing if you have said what happens. Well, first of all, what definitely happens is it increases. It goes from 750 to 3,000. That's definite increase. So as the turbine size or the radius increases, so does the power rating. So key word here is increases. It increases. Now, we can go into, can you give any more detail about this? So you probably get the marks for the word increases, but it's better if we can give more detail. Can you say any more about the increase? So pause the video and see, can you make this answer better if you haven't already? Okay, so one way we could do this is say it increases from 2. Okay, so if we didn't do this, you could write this sentence, increases from 2. Pause the video and do this now. Okay, well, it increases from 750 kilowatts to 3,000 kilowatts. So again, this will be describing in more detail than just saying increases. Another way you could do this, I want to do an alternative one in blue, is it increases by, some of you may have noticed, the actual size of the increase. You could say it increases by 2,250 kilowatts. That would be even more descriptive. I'm going to write one more version of this underneath. What you could have said, increases by a factor of 4. And what this means is that 3,000 kilowatts is 4 times bigger than 750 kilowatts. So you see there, the different levels of describing we could do. I would say that this answer is probably the best one. This is probably the most complicated answer. Then this is probably the next most complicated, and then this is probably next most complicated. Just increases is too simple, guys. You might not always get the full marks for that. So when you're asked to describe, be as descriptive as you can. Right, on to the next one. Give one advantage of using this method to generate electricity. So one good point about it. Okay, so pause the video and try and write down at least one advantage of generated electricity. Okay, now that you've done that, some of you are really good and you'll know your stuff here. So here's another chance to pause the video and write down 1 or 2 more, as many as you can. Pause the video, do that now. All right, these are some of the things that we could say. You could say it is renewable. Renewable. And what that means is, if it's renewable, is you can keep doing it forever, and it's not going to run out of anything. So it can never run out of wind. So it's renewable. It is natural. It is natural. It's not like burning fossil fuels or whatever. It's cheap in the long run. So there might be a cost associated with setting it up, but it's cheap in the long run. It pays itself back long run, or it's cheaper over time, you could say. Another thing is that it does not release carbon dioxide. No carbon dioxide emitted, and that's a massive one when it comes to energy. We know the issues surrounding that. Okay, all right, so those are the advantages. Next one, it says one disadvantage of this method of generating electricity is that no electricity is produced when there is no wind. So no electricity, no wind. But it says give another disadvantage of this method of generating electricity. Now in the exam, some of you said it doesn't work when there's no wind, but it's already told you that, and it says to give another. So you get 0 marks for saying it doesn't work when there's no wind, because they've already said that. Yes, we know that, but we want a different one. So pause the video and make sure you write a different disadvantage down. Pause the video, do that now. Okay, so for part C, you should be writing another disadvantage of wind. Okay, a couple of them here. It can be expensive. Can be expensive to set up. Costs a lot of money up front. It does pay back in the long run, but sometimes people don't want to spend that money up front. Some people don't like the look of them. So you could say unsightly or ugly or destroy the landscape, something like that. Noise pollution. Noise pollution. And some people complain about vibrations. A lot of vibrations in the area. They kill birds, they kill wildlife, especially birds. Kill birds. You could say that they make a humming noise or an annoying noise, but a lot of my students got this one right. They said noise pollution, or they said they're too noisy. But there are some other ones to think about as well. Okay, so the next question says, the power output of 2 wind turbines, A and B, was measured at different wind speeds. It says the results are shown in the table below. So here are the different wind speeds, which we see represented on the graph down here. Look, here is the wind speed, and it goes up 0, 5, 10, 15, 20, and 25, and so on. And it says the power output was measured for 2 turbines. So this here is power output. Look what we have on the y-axis is power output. Now what we have here is we've got 2 sets of numbers, okay? 2 sets of numbers. Now, a lot of my students did this wrong because, no, not a lot, but quite a few students, they tried to do bar charts for this. Now, when do we know when to do a bar chart and when to not do a bar chart? Okay, so the first thing here is this would be a bar chart where we have a scale where some are numbers like this, so 10, 20, 30. And then on one of the axes, either the X or the Y, you don't have numbers, you have categories. And categories are described using words. An example of this would be colors, say red, orange, blue, and so on. That's a category. Or names, John, Michael, so on. Where you have a list of categories and a list of numbers, you use a bar chart. Bar charts are for categories. So we say 20 were red, 30 were orange. So when there's not a set of numbers here, we use a bar chart. When there's 2 sets of numbers on the axis, like this, where this is a set of numbers, 10, 20, 30, and this is another set of numbers, 10, 20, 30, 40, well, then we usually use a line graph, which means we plot the points. So we say, okay, if temperature is 10, or sorry, temperature, yeah, if this shows temp and this shows, say, the rate of a reaction, rate, and this is temp, well, then we use a line graph. So say when the temperature is 10, the rate is 10. When the temperature is 20, the rate is 20. We plot points like this. When the temperature is 30, the rate is 30. And then we usually draw a line of best fit through the points like this. So key thing, on the axis, where one set of numbers and one set of categories, words, we use a bar chart. When we have two sets of numbers like this, tens, 20, 20, then we use something called a trend graph or a line graph. When we plot the points and we then join the points by a line of best fit. So notice here, what are we measuring? Wind speed with numbers 0, 5, 10, 15, and power output with numbers 10 and so on, 1,000, 2,000, 3,000. So this here is definitely going to be a trend graph. But the thing is that there are two sets of results. There's turbine A and turbine B, which means we need to do them in different colors. So, and notice what it says here. In the space below, draw a graph of the results for both turbines. Label the graph clearly for each turbine. So using a purple points and a purple line, we're going to use turbine A, and we'll use a different color, and this is good practice for you to do, using a blue line and blue points, we're going to do turbine B. So what I suggest that you guys do is, if you've got your exam paper and it's empty here, we're going to draw that graph here. If you want to rub it out, if you did it in pencil and do it again, rub out. If you did a bar chart, rub it out and do it again, or Tipp-Ex it out. Or if none of them are an option and you don't have this paper, or you've done too much messing on it, then if you get a sheet of graph paper and just copy out the two axes like this with the numbers on it, and then we'll draw it together. Okay, so I'm going to get you started on the turbine A using blue points. So it says here, for turbine A, when the wind speed was 5, the turbine power output was 200. So what I'm going to do is go over to 5 for wind speed and up to 200. Now, that point is very low because 200 is between these first box, because this here is 500. This is 0, 500, 1000. So 200 is probably somewhere like around here, just there. Let's go to the next one. It says for 10, wind speed 10, turbine A was going 500 speed. So 10 and 500. So I just mark a little X where it belongs. 15, at 15, it was 1,200. So I'll go to 15, I'll go up to 1,000, and then a little bit more for 200. All right, so I'm going to get you to pause the video and finish off the other 2 points for turbine A. Pause the video and do that now. All right, so you should only be playing if you finished off this chart. So here is when the wind speed was 20, turbine was going 2,200. So 2,200, just a little bit above 200, just there. And then 25, it was 3,500. So it's jumped up now. It's there. And then what we're going to do is we're going to draw a line of best fit. So a smooth curve through the points. Don't use a ruler. A smooth curve. Okay. What we're now going to do is switch to a different color pen, and we're going to do the results for turbine B. I'll do the first one. For 5, it was 500. So 5, it was 500. Started there. You do the rest. Pause the video and finish the rest for the blue line for turbine B. Okay, so show me playing if you have got turbine B done. So it is 10 is 1,400, which is just about there. 15 is 3,000. So there, like that. 20 is, where are we? 5,200. Just there. And then 25 is 7,600, which is a way up here. And there we go. Smooth curve. Yeah. All right, so now we've labeled A and B, and we've plotted the points, and we've drawn them with a line of best, joined them with a line of best fit. All right, now it says use your graph to find the power generated by a turbine at a wind speed of 17. Well, we don't have a point up here for 17. We only have 15 and we have 20. What we can do is find on our graph where 17 is. So I'm just going to give you a chance to pause the video and have a go at this yourself. Pause the video and do that now. Okay, so if you haven't got this done, maybe I can help you. It says go to wind speed 17. Well, look, here's wind speed, and wind speed here would be 17, which would be right here. So now pause the video and go and find out how much power is generated by turbine A at this speed. Okay, so how do we do this? Well, what we do is we take a broken line from 17 up until it hits turbine A, which is this purple line. And then we go across with our ruler and we find out what the power output will be. Well, it hits the line here, which means that's halfway between 1,000 and 2,000. So it's 1,500, and this is watts. Right, the next one, it says use your graph to find the wind speed required by turbine B to generate 6 kilowatts of power. Pause the video and do that now. Okay, here's 6 kilowatts of power. It hits B there and it comes down to here. So it's about 22 kms per hour. Right, guys, that's that question. All done. Hopefully that helped a lot. And the big thing is remembering when bar charts are used and when trend graphs are used. Make a note of that if you got it wrong and make sure we try and remember that for next time. All right, we'll see you in the next video.